Have you ever wondered why metals rust? Why the shiny surface of a new bicycle turns into a dull reddish-brown after some time? This isn't a magic trick. It's not a curse inflicted upon our precious metals. It's a natural process known as corrosion. Picture this. You leave a shiny new penny in a glass of soda overnight. The next morning you find that the penny has turned green. What you're seeing is corrosion in action. Corrosion is that silent destroyer that slowly but surely gnaws away at our bridges, cars, and even the very pipes that carry water to our homes. It's a phenomenon that's as old as the metals themselves, and yet it holds a sense of mystery. After all, how does something so solid and shiny transform into something so brittle and dull? Corrosion isn't just about rusting iron or tarnishing silver. It's a universal process that affects all metals, albeit in different ways. From the majestic Statue of Liberty to the humble kitchen knife, no metal is safe from the clutches of corrosion. Now, you might be thinking, why should I care about corrosion? Well, aside from the obvious fact that it can damage our belongings, understanding corrosion can actually help us prevent it. But wait, there's more to it than just prevention. Believe it or not, corrosion plays a vital role in our daily lives. It's the reason why batteries work. It's the process that gives us those beautiful green patinas on old copper roofs. It's a fascinating world of chemical reactions just waiting to be explored. So buckle up, because we're about to embark on a journey into the microscopic world of metals. We'll dive into the nitty-gritty of atoms and electrons. We'll unravel the secrets behind the scenes of this everyday phenomenon. Today, we'll unravel the secrets of corrosion, a process that might seem destructive, but is actually an interesting chemical reaction. To understand corrosion, we need to dive into the world of atoms, ions, and electrons. Let's imagine a bustling city where atoms are the citizens. Their wealth is determined by the number of electrons they possess. In this city, there's a group of atoms known as metals, and they are known for being generous with their electron wealth. One day, a new atom moves into town, and this atom is oxygen. Oxygen is a bit of a hoarder and is always on the lookout for extra electrons. Now, when a metal atom meets an oxygen atom, the metal atom gives away its electrons to oxygen. This process is called oxidation, and it's the first step in the chain of events leading to corrosion. As the metal atom loses electrons, it becomes positively charged and is now an ion. This ion is no longer a part of the metal structure, it's now free to move away. Meanwhile, the oxygen atom, having gained electrons, becomes negatively charged. It attracts other elements like hydrogen to form water, or in some cases, it might form rust with the metal ions. This is the basic process of how corrosion happens at the atomic level. But there's another side to the story. While the metal atom is losing electrons somewhere else, another atom or ion is gaining those electrons. This process is called reduction. Together, oxidation and reduction form a process called a redox reaction, which is the fundamental chemistry behind corrosion. Now, imagine this process happening on a grand scale, with billions of metal atoms losing their electrons. Over time, this results in a visible change on the metal surface, the formation of rust. Corrosion, therefore, isn't just about the destruction of metal. It's a story of atomic interactions, of give and take, of oxidation and reduction. It's a tale of how even the hardest of metals can be worn down by the relentless pursuit of oxygen for electrons. So in essence, corrosion is a process where metal loses electrons and gets oxidized, leading to the formation of rust. Not all metals rust at the same rate. Ever wondered why? The answer lies in the variety of factors that influence corrosion, which we'll delve into now. Firstly, the type of metal plays a significant role in determining the rate of corrosion. For instance, iron and steel are notorious for their susceptibility to rust, while aluminum and copper resist corrosion due to a protective oxide layer formed on their surfaces. Gold, on the other hand, is almost immune to corrosion. Hence, the chemical properties of a metal largely dictate its resistance to corrosion. Secondly, the presence of water and air, specifically oxygen, is vital for corrosion to occur. This is because the process of corrosion is essentially an electrochemical reaction involving metal, oxygen, and water. The more moisture and oxygen present, the faster the corrosion. Now let's talk about environmental conditions. The temperature, humidity, and even the salt content in the air can speed up corrosion. Higher temperatures can accelerate chemical reactions, leading to faster corrosion. Similarly, higher humidity levels can provide the moisture needed for corrosion. Ever noticed how seaside towns seem to have rustier cars? That's because salt water speeds up the process, leading to what's known as salt spray corrosion. The pH of the environment also plays a role. Both highly acidic and highly alkaline conditions can speed up the corrosion process. This is why car batteries, which contain strong acids, often show signs of corrosion. Lastly, the presence of certain bacteria can influence corrosion. Some bacteria produce byproducts that can corrode metal surfaces. This is especially a problem in industries like oil and gas, where bacterial corrosion can lead to significant equipment damage. So the rusting of metals is not just a simple process, but one that's influenced by various factors. Understanding these factors can help us better protect our metals and prolong their lifespan, a topic we'll dive into in our next segment. Now that we know why metals rust, the question is, how can we prevent it? The answer may surprise you with its simplicity. We combat corrosion, not through one, but through a variety of methods. One of the most common methods is coating the metal. This could be as simple as painting the metal or as complex as electroplating it with a thin layer of another metal. The goal here is to create a barrier between the metal and the environment. This prevents water, oxygen, and other corrosive substances from reaching the metal surface and initiating the corrosion process. But what if we could use a metal that doesn't corrode easily? That's another method. Some metals, like stainless steel and gold, have a naturally occurring protective layer that prevents them from corroding. These metals are known as corrosion-resistant metals. They're often more expensive, but their long-term durability can make them a cost-effective choice in the long run. Yet another method is to control the environment around the metal. This could be by reducing the humidity, controlling the temperature, or even altering the chemical composition of the environment. By doing this, we can slow down or even stop the corrosion process. For example, storing a metal object in a dry place can significantly reduce the rate of corrosion. Interestingly, we can also use a method called cathodic protection. This involves connecting the metal to be protected to a more active metal. This active metal corrodes instead of the protected metal. It's a bit like having a bodyguard for your metal. As you can see, combating corrosion isn't a one-size-fits-all solution. It requires an understanding of the metal, the environment, and the specific needs of the situation. But with these methods, we can protect our metals and keep them shiny and new for a longer time. So the next time you see a rusty old bicycle or a corroded bridge, you'll know that there are ways to prevent that from happening. With these methods, we can protect our metals and keep them shiny and new for a longer time. So, corrosion, as we've seen, is not just about metals turning rusty. It's a complex process, a dance of chemistry and physics that plays out on the surface of materials. It's an inevitable part of life, but it's also something we can understand, control, and even combat. Remember, corrosion is all about a material's interaction with its environment, a slow but relentless tug of war between the forces of nature and the substances we've crafted. It's a process driven by electrochemical reactions, where metals return to their original state, breaking down and merging back with the elements around them. But corrosion doesn't occur in a vacuum. There are numerous factors that influence the rate and extent of corrosion. The environment plays a crucial role, with aspects like humidity, temperature, and the presence of certain chemicals all contributing to accelerate the process. Even the type of metal and its properties can determine how susceptible it is to corrosion. Yet, despite corrosion's inevitable march, we're not defenseless. We've developed a myriad of methods to combat it, to protect our structures, our machines, our artifacts. From the application of protective coatings and the use of corrosion-resistant materials, to the implementation of cathodic protection and regular maintenance, we have a whole arsenal at our disposal. Corrosion might be a natural process, but understanding it gives us the power to mitigate its effects, to make our creations last longer, and to better protect the resources we have. It's a testament to human ingenuity, our ability to understand and manipulate the world around us. And that's the beauty of learning, isn't it? To peel back the layers of the world, to understand the why and the how, to see the unseen. It's a journey that's never ending and always fascinating. So, If you're as intrigued as I am, if you want to keep learning, to keep understanding, to keep exploring, then join me. If you found this video interesting and learned something new, don't forget to subscribe for more because you won't find me later. Stay curious, stay informed.